Good morning. So today our topic is method overloading and constructor overloading. So what is method overloading? So before going to method overloading, already we know what is the method. So method is a set of instructions to perform a specific task. So here what is method overloading? So method overloading is a feature that allows a class to have multiple methods with the same name. So simply what is method overloading means a class allows multiple methods that have the same name but with different number of parameters, sequence of parameters and type of parameters. So the method overloading is also called as compile time polymorphism, static polymorphism or early binding polymorphism. So these are the another names for the method overloading. So how the method overloading is achieved in Java? Here we have the three ways to achieve the method overloading. One is the based on the number of parameters. Second one is the data type of parameters, and the third one is the sequence of data type of parameters. So here we have the same method name but with different parameters, with different data types of parameters or with sequence of data types of parameters. First we can see the example for the number of parameters. Consider a method name add. For this method we have two parameters. Again consider the same method name add. Now here you consider three parameters. So what is method overloading? The method overloading is a same method name but with a different number of parameters. So the first method is used to add the two integer values. The second method same add is used to add the three integers. Similarly, the method overloading can be achieved using data type of parameters also. So here we have the same method name but different types of data types. Consider add is a method name. So in the first method we can pass two data types. One is the integer data type, second one is the integer data type. So this is the one method name. Here we can take another method name add, but here we can pass different parameters. One is the integer parameter, another one is the float parameter. So that means the first method add is used to add the two integer values. Similarly, the second method name add is used to add the one integer value and one float value. So here data types are changed but the method name is same. Next, third one is the sequence of data types of parameters. So first one is consider method name add. For the first method name add we have the two parameters. One is the integer data type, second one is the float data type. Next, same method we have the add. In this case we can change the parameters. You can change the data type, sequence of the data types. One is the float, second one is the int. So the first method add is used to add the integer value and float value. Similarly, the same method name add is used to add the float value and integer value. So in this way we can use the same method name but depend on the number of parameters, depend on the data types of parameters or depend on the sequence of data types of parameters. We can perform method overloading concept. So now we can see example of this method overloading. So this is the example for the method overloading based on the first concept. The first concept is different number of parameters. So we can use the same method name but we change the number of parameters. Here first we can write a class name, class overload x we can write a method name add. Here we are passing the two parameters int a comma int b. Now we can performing the sum equal to a plus b return sum. So this is the one method name. This is the method name, method with the name add. Next we are writing the same method name again add, but here the number of parameters are changed. So in the first method we are using two parameters, but in the second method we are using the three parameters. So that means same method is used for addition of two integers. Similarly, the same method name is used for the addition of the three integers. So now we see main program. Public static void main overload ex obj equal to new overload ex. We are creating the object. So using the object we can call the method. So object dot add 20 comma 30. Here number of parameters are 2. So it will call the first function. Next second one object dot add 15 comma 20 comma 30. Here the number of parameters are 3. It will call the second method. So the same method name is used for addition of two integer values. Similarly for addition of the three integer values. So for the first method the output is 50. For the second method the output is 65. So this is the method overloading. So method overloading means same method name is used for different purposes. Next similarly constructor overloading. So constructor overloading, already we know about the constructor. So similarly just same as the method overloading. So constructor overloading is also we have the same constructor name that can be used for different purposes based on the number of parameters, sequence of parameters or type of the parameters. So in the constructor overloading we can use the same constructor name, but that can be used for the multiple purposes. So here we can see the example class student. That two variables, instance variables int id. Second one is the string name. Third one is the int age. So we are writing a constructor student. So using this constructor we can assign values to id and name. So I is passed to the id, next n is passed to the name. So this is the one constructor. Already we know the constructor name is same as the class name. So the class name is student. Therefore the constructor name is also the student. Next we are writing the same constructor. We have another constructor with the same name student, but with three parameters int I comma string n comma int a. So I value is moved to the id, n value is moved to the name, a value is moved to the age. So using the first constructor we are assigning the providing the values to id and name. So by using the second constructor we are providing the values to id, name and age. So these are the two constructors. Now we can see the main program for this one. The main program is public static void main string args. Here we are calling the first constructor student s1 equal to new student 246 comma Gopal. So based on the number of parameters, here we are passing the two parameters 246 comma Gopal. So it will call the first constructor. So in the first constructor id equal to 246, next name equal to Gopal. So next we will call the s1 dot display. So whenever we call the s1 dot display, it will print the id value, name value. So id equal to 246, name equal to Gopal. So this is the first calling constructor. Similarly we can call the second constructor student s2 equal to new student of. So here we are providing the three parameters. One is the 248, second one is the Ramarao and 25. So based on the three parameters it will call the second constructor. So after this id equal to 248, name equal to Ramarao, age equal to 25. So now we can call the s2 dot display. So it will print the values of id, name and age. So by using the constructor overloading also we can write a example program. So the purpose of the constructor overloading is we can use the same constructor name for multiple purposes, same as the method overloading. Next one is the this keyword. So what is the purpose of the this keyword? So this keyword is used for to differentiate the instance variables with the parameters. So to differentiate the instance variables with parameters. So this keyword can be used to array class instance variable. If there is ambiguity between the instance variable and parameter, this keyword resolves the problem of the ambiguity. So simply this keyword purpose is differentiating the instance variables, and next one is the parameters. Now we can see without keyword what is the problem was occurred. So first one we can take the class student. We are taking the three instance variable, int roll number, string name, float fee. Here we are writing the constructor. So constructor is used to pass the value, assign to the values to the instance variables. So the roll number is passed to the roll number, name is passed to the name, fee is passed to the fee. So we are using the same names for the both instance variables and the parameters. So in this case the problem was occurred is ambiguity problem was occurred. Why? Because which is the instance variable and which is the parameter. So the compiler does not understand which is the instance variable and which is the parameter. So in this case ambiguity occurs. So whenever ambiguity occurs, the JVM or compiler provide the default values. Next we can use the another method, display method. Display method is used to print the roll number, name and fee. So whenever we pass values to the constructor, so because of ambiguity these values cannot pass it to the id, name and fee. So in that case it will print the null zero value, null value 0.0. Why? Because integer default value is 0, string default value is the null, float default value is the 0.0. So whenever we are not using this keyword, ambiguity occurs. In this case the compiler print the default values. Default values of the integer is the 0, default values of the string is null, default value of the float is 0.0. So to solve this problem we compulsory use this keyword to differentiate the instance variable and the parameters. Now we can see by using this keyword how we can solve this problem. So see another example how we can solve the previous problem using this keyword. Example, class student. We are taking the three instance variables, roll number, name, fee. Next we are writing the constructor to provide the values to the instance variables. Next here we are using this keyword, this dot roll number equal to roll number. So in this case we can clearly differentiate which is the instance variable and which is the parameter. So the roll number is the parameter, this dot roll number indicates the instance variable. That means the parameter value is passed to the instance variable value. Similarly name is passed to this dot name, instance variable name. Similarly fee parameter is passed to this dot fee instance variable. So whenever we use this keyword we can clearly identify which is the instance variable and which is the parameter. So now we can see another method to print the values, system.display method. So using the display method we can print the roll number, name and fee. Now we can write a main program. Student S1 equal to new student of 246 Gopal 6500 float value. So by using this, it will call the constructor. It will call the constructor. So here the port for 246 is moved to the roll number and name is moved to the Gopal and 6500 is moved to the fee. So the roll number value is the 246 and the name value is the Gopal and the fee value is the 6500. Now the 246 is moved to the roll number instance variable. Similarly, Gopal is moved to the name instance variable. Next, 6500 is moved to the fee instance variable. Now the instance variables are assigned to 246, Gopal and 6500. So now we can print the S1.display. So S1.display method calls the display method. It will print the roll number value, name value and fee value. So roll number value is the 246, space name value is the Gopal and the fees value is the 6500. So this is the output for the S1.display. Similarly, we can use another constructor. So for the second object, student object, we are calling the construct. We are providing the values 248, Ramkumar and 7000. So here the 248 is moved to the roll number, Ramkumar is moved to the name. Next, 7000 fees is moved to the fee. So now the 248 is moved to the instance variable roll number. Next, Ramkumar is moved to the name instance variable and 7000 fee is moved to the fee instance variable. So whenever we call S2.display, it will print the roll number, name and fee. The output for this statement is 248, Ramkumar, 7000. So this is the output. So this is the example how we can solve the ambiguity problem using this keyword. So when we use the different names for the instance variable and the parameters, in this case no need to use this keyword. For example, same program we can write another way. So first I am writing a constructor student. The parameters are int r, comma, string n, comma, float fee, float f. In this case we are giving the different names. Instance variable names are roll number, name, fee, but the parameter names are r, n, f. So there is a different names. So in this case no need to use this keyword. Simply roll number equal to r, next name equal to n, next fee equal to f. So that means r value is moved to the roll number, n value is moved to the name and the f value is moved to the fee. So whenever we are providing the different names to the instance variables and the parameters, in this case no need to use this keyword. So this keyword is used only whenever the local and whenever the instance variables and the parameters have the same name. In that case only we can use this keyword. Otherwise no need to use this keyword. Next one, garbage collection and finalized method. So what is garbage collection in Java? So in Java the garbage collection purpose is to perform memory management automatically. So to perform the memory management automatically, we can use the concept of the garbage collection. So garbage collector purpose is finding the unused objects, and delete them to reclaim the memory. So generally we are creating the objects in Java. So some objects are useful, some objects are not useful. So that unused objects need to delete them and reclaim that memory. So for that purpose, we can use the garbage collection. So generally, an object can be unreferenced using three ways. One is the nullifying a reference. Second one is the assigning a reference to another. Third one is the by anonymous objects. By these three ways, there are unused objects. First one is the by nullifying the reference. Here we are creating a object E for the employee class. Now E equal to null. That means E is the unused object. So in this case, we need to delete that object and recover the memory. Second way, similarly, we are creating two objects, E1 object, and similarly we are creating the E2 object. Now E1 equal to E2. So in this case, the previous E1 object is the unreferenced object. So in this case, we need to delete the E1 object. Third case is the anonymous object. So we are creating the objects without names. So in that case also, we need to delete the unused objects and we can recover the memory. So we can see how we can achieve the garbage collection. For that, we have the two methods. One is the finalize method and second one is the GC method. So the finalized method purpose is before destroying the object, the garbage collector calls the finalized method. So to perform the cleanup activities. So before destroying any unused object. So in that case, the garbage collector initially calls the finalize method. Similarly, the syntax, the method how we can write is the protected void finalize method. So we can write this method in this way. Next, another method is the GC method. So GC method is used to invoke the garbage collector to perform the cleanup activities. So how to write the GC method? That is the public static void GC. So this is how we can write the GC method. So the GC method is generally in the system class. The GC method is generally in the system class. The finalize method is in the object class. Now we can see one example how we can call the finalized method before destroying the object. This is the program. See, first we are creating a class. Next we are writing a finalize method. System.out.println object is garbage collected. Now we are creating object. G1 is the one object and another object is the G2. Now G1 equal to null. Whenever G1 equal to null, that means G1 is unused object. So in that case, we need to remove the G1 object. We can recover the memory. Similarly, G2 equal to null. So G2 is also unreferenced. So that means we need to delete the G2 object. So here we need to delete the both G1 object and G2 object. For that we can call system.gc. Whenever we call the system.gc method, before destroying the object, the GC method calls the finalize method. So first G1 method, G1 object is removed and claim the memory. So before removing the G1 object, it will call the finalize method. So it will print object is garbage collected. Then similarly, G2 equal to null. That means we need to remove the G2 object. So here also the finalize method was called before garbage collected. So in this case also output is garbage is object is the garbage collected. So before removing the objects, it will call the finalize methods. So this is the how we can use the finalize method. So this is the garbage collection. So 2 minutes. Next, last one, command line arguments. What is the purpose of the command line arguments? The command line arguments in Java is used to pass the arguments during the program execution. So the command line arguments are used to pass the arguments during the command line during the execution of the program, where we can store these arguments. The arguments are stored as the strings in the string array that are passed to the main method. So now we can see one example. Class command line example. We are writing the main method. Here the system.out.println. Your first argument is argument s of 0. See, now to run this program, first we need to compile. How do you compile? Java C command line ex.java. Now we need to pass the argument value. Java command line ex space Gopal. So now the Gopal is the command line argument that is moved to the argument of 0. So whenever we print your first argument is arguments of 0, it will print the Gopal value. So in this way we can pass any number of arguments. For example, we need to print args of 0 and args of 1. So in this case we need to pass the two values. One is the Gopal value, another one is the Ram. So Gopal is moved to the arguments of 0 and Ram is moved to the arguments of 1. So the output is Gopal and Ram. So this is about the command line arguments. So generally the command line arguments are used to pass the values during the program execution. Okay, thank you.